Hey everybody, my name is Joe Dunnigan. I am the Interactive Services Team Lead at Network Center. I've been with Network Center for 8 years and been running the dev team for a couple of years now. I am here today to talk to you about using application development to further your business. So on the dev team, on Interactive Services, we spend a lot of time building a lot of different types of products and solutions. Anything from websites to mobile apps to ERP systems, custom data integrations, big IoT platforms, lots of fun stuff. We love to build cool, fun things. What I'm going to do today is I'm going to take you through a couple of different case studies, different types of applications that we build, and how they could possibly relate to your business, how our customers are using them, and what the different applications can be for those systems. So I'm going to talk about ERP systems, and I'm going to talk about systems integrations, data analytics, and native and hybrid cloud. So looking at ERP systems, we have a couple of case studies here that I want to go through. ERP systems can be, they can fulfill a lot of different needs. So it's kind of a blanket term that we use to generally just talk about business applications that are going to perform business functions. So the first one that I'll look at is an ERP system that we would say it's both an ERP running business functionality and a combination of also an intranet that's performing various functions and storing and housing data for employees to access, whether it's for HR or for sales or for general company communications. So this intranet, this is an ERP. This is serving a 500 plus employee business. And again, it's performing a lot of different types of functionality, and it's grown over the years. The great thing about some of these systems that we build is that we have an initial build where we build out features and functionality, and then the application continues to grow over time. So this thing's been out in the wild for probably 5 or 6 years, and we've continued to update and add features and functionality over time. So it's continued to grow, major upgrades and overhauls. It's still performing all of the core functions that it started with, but it's grown to meet the continuing needs of the business. So a couple of things that this system is doing. It started out mainly for the sales team and the IT team, and then again to perform some basic company communication and HR functionality. So we've got product quoting and invoicing and maintaining a CRM system, so to speak, with customer data, customer records, contacts, those type of things. Creating sales quotes, turning them into invoices, workflows for emailing invoices, handling product orders, inventory, lots of different stuff going on in there. And the IT portion was actually a pretty big piece of this. So small IT shop handling a couple hundred users, and they needed a ticketing system, or they wanted an upgrade to their ticketing system, their help desk ticketing management. They wanted to build out more robust inventory management, asset tracking, software inventory, software lifecycle, licensing, lots of different things that can go into that, as well as a general knowledge base for their team to be able to maintain how they are managing the software that they use, the systems that they build, PC images, server builds, all those different kind of things. Later on in the system's lifetime, we ended up adding in warehouse inventory management, which was a big addition to the system. And we then later added worker safety components. So they have construction crews, they have workers out in the field, they have to meet various regulations, MSHA, and so forth. So tracking incidents, tracking things like CDL driver licenses, various requirements that they had. So tracking renewals, all that kind of stuff. So they have a centralized system for managing all of those various types of business requirements and keeping track of these different business processes. So that's study number one. Case study number two. So this one is, I'm actually going to talk about two different systems that are similar here that we have out in the wild that we built, manage, and maintain. Both of them, one is really heavy on the manufacturing side. The other one is more focused on, let's call it service technicians that are out in the field, as well as both systems have a good component of the sales process as far as quoting, invoicing. So on the manufacturing side, there was some really cool stuff that went into that system. So they're manufacturing a product, and the way that they start that process is by quoting a customized product that may have varying dimensions, varying components. So they build a quote, and out of that quote comes the specs for the product. So how many nails and screws it needs, and how many struts it's going to have, a lot of various components to that product. So we actually produce CAD drawings out of the system. We produce parts lists. And so those documents will be taken to the floor where the product is manufactured. And so a lot of interesting business logic going on there, a lot of interesting functionality. Moving beyond the manufacturing piece of it is managing service technicians out in the field, both doing installations of new product and servicing existing products, tracking warranty, tracking customer installations, tracking products out in the field over time, allowing service technicians to be alerted to a new job when they're out on the road. So making sure that this is accessible from a mobile device, from a tablet, from a computer, became more important over time. Wasn't initially a target goal for the system back when it was built, but then a couple of years later, realized that they could get a lot more out of it if they were able to extend it out into the field. So things like if I'm a couple hundred miles out of town on a job, maybe another job pops up close to me within 40 miles, right? So back in the day, maybe they would have caught that. And they would have been able to call the technician and say, hey, can you also go to this other job while you're out there? But maybe they didn't catch it, and then it would be a couple more days before they could get back out there. Now, that can be instantaneous with notifications and alerts, doing close to me, GPS-based tracking of jobs and service. So really expanding on the capabilities there. And the next area where that continues to grow, where those systems continue to grow, is taking the data that's in the system, that's been put into the system over the past 5 years, and starting to learn from and understand that data and use it intelligently, right? To perform analytics on it, to say, we've been tracking where our sales quotes are coming from now for these past 5 years. Well, let's start to look at where we're winning the most jobs. Is it a trade show that we went to, or is it a certain dealer that is selling more of our business? and use that in order to do targeted sales and grow the business that way. So a lot of good things that can come out of that. Okay, so the next ERP I'll talk about last, I believe, ERP that I'll talk about is a project management system that we started developing about a year ago. It's an interesting use case because we're developing it for our customer, and they in turn are making it available to their customers. So it's essentially software as a service project management for a specific type of industry. And so this engineering firm is opening it up to their customers and saying, here, we have a new way for you to manage your projects. You can sign into this system. We'll help you manage and maintain. Since they already manage and maintain these projects for their customers, now they're just giving them new and better ways to access that information on the go. Again, tablet and mobile accessible. So instead of having to just deliver packets of paper for upcoming projects, now they can get real-time access, assist in creating the project scopes and deliverables, and make the process much more interactive. This system was a rebuild from a Microsoft, or MS Access database. And we've done quite a few of those over the years where something started in-house on Access, and over time, they started to outgrow its capabilities. Or they found, there are shortcomings at times. So we took this system to the web where it was accessible anywhere, anytime by anyone, as opposed to when it was a Microsoft Access database. It was on a network share. Only one person could be in editing it at a time. And it was locked to the building, right, to the local network. So we took it, made it into a web app, and vastly expanded its capabilities just from that perspective. And again, we bring with that rich reporting, data analytics, and the ability for a system to grow over time to meet the new and changing needs of a business as the business grows. All right, so the next one I'll talk about a couple of data integration projects. So a lot of the data integration projects we do are going to be taking either in-house or third-party systems, 2 or more systems that each have pieces of data that we're interested in, and finding ways to bring together and relate that data together and present it, whether it's by BI or some other means of reporting, or if it's simply to get data from one system to another. So in this particular case, we're looking at a time clock system and a staff scheduling system. So both were third-party products. Both were already web products, but the customer needed to be able to have those 2 products talk to each other. First and foremost, to import and export employee information from one to the other. So we create an employee in one system. We wanted to create that employee in the other system so they have the same ID, they have a common identifier, and we can share information that way. Then moving forward, each of these 2 systems performs a role, but they do overlap in cases. Things like time off requests or sick leave were entered into one system but needed to be available in the other system. So getting rid of dual data entry, if nothing else, having to enter the data twice, possibly making mistakes by hand entering data. So sharing those various pieces of information between the 2 systems was the goal here, basically to automate features and functionality, right? Second data integration is pretty interesting. It was a small build, but there's some cool aspects to it. So what this one was a real estate company that wanted to allow their users to look at a sign and see a code that they could text in order to get more information about the house, right? So what they really wanted was if someone text a code for this house to us, we want to send them back to the URL that goes to our website. They were using a third-party vendor in order to do the signage and the text codes, but the third-party vendor couldn't quite get that last mile of, we're going to be able to grab the link for this website dynamically for this property and send it back to the user. So we integrated with that third-party system and wrote the logic in order to translate the code that was being sent into the ID of the home, create the URL, and send it back to the user via SMS text message. So small integration as things go, but pretty powerful as a full solution. And this was a product that we built on a full serverless implementation. So when I say serverless implementation, what that really means is we wrote the code and it's running, and it's either running on a schedule or it's responding to an event such as an incoming text. The code only runs when that event happens. So we don't have to have a server sitting there with the application, with the code running on it. It's sitting dormant, not costing us any money until an event actually happens, until a text message actually comes in. So we only have to worry about the code then as developers. We don't have to worry about the infrastructure that it's running on, the network, the server, the compute, storage, all the other things that go along with. You need an application up and running in the cloud, right? Or you need an application running, period. The other thing it affords us is that with a couple other, I'll talk more about serverless in a couple more slides, because I do get pretty excited about it when I get going. But we're only paying for the time we're using it. So if we only get 2 text messages a day, we're only paying for the time that the function ran in order to service those 2 text messages. If we get 100 a day, we pay for the 100 text messages. So not only are we only paying for what we use, but we are scaling with usage and with demand, and hopefully scaling with business, right? If you're getting more demand, then that should be translating into more business. We hope the business model provides that. So we can scale with business growth. If it's not getting used, you're not paying any money. If it's getting used a lot, then you start paying. But also, I should have provided the calculations. I believe how it worked out was we estimated if we had 5,000 text messages come in a month, it would cost us 7 cents in order to support this system. So pennies, almost nothing. If we had built this with the same capabilities, highly available, multi-data center, which is what we get out of the box with a service like AWS Lambda or Azure Functions, if we had tried to build that architecture ourselves, we would be easily looking at hundreds of dollars a month, if not more. All right. Oh, I slid in a fancy little graphic. But I feel like it's at the wrong spot. Maybe I'll come back to it. Yep, that one too. All right, well, let's talk about hybrid cloud at scale. So this is where things start to get fun with serverless and cloud services and looking beyond, let's say, looking beyond just IaaS, looking beyond just storage and compute and network, and talking about there are hundreds of cloud services inside of AWS or Azure, right? There's hundreds of different services. More than anyone really can be aware of at any given time. New services are coming out every day, every week at least. So expanding to understand how we can utilize those systems, knowing the tools that we have available to us in our toolbox if we're presented with a problem or an idea and we're going to build a solution to it. So talking specifically about this case study where we needed to build a system at scale to service millions of end users, we needed secure and scalable identity management. robust SSO, high availability, DevOps that I want to talk about a little bit more, and rolling that all into a system that was reliable, and also speaking to the fact that this was going to be deployed into a highly regulated industry. More than ever, security was top of mind, and our first consideration at every step was this has to be secure beyond a shadow of a doubt in every component. So, so we go down and we talk about the refined DevOps practices. Really what we were looking at there is, if we're going to develop a system that is going to need to achieve this reliability and this state of security, our practices for developing it have to meet those same standards. And what that really means is we need to be able to test at every step of the way, and we want to automate testing and deployments as much as possible to remove any manual interaction that has to happen at the system while it's in use or while we're deploying new features. So that's where DevOps really starts to shine for us, is removing manual human steps and automating the process so that it's always a known, we always know what's going to happen, and we can catch failures faster, understand them better. So as part of this project, as part of building out this highly available consumer-facing system, we worked with this organization to implement DevOps practices along the way, to improve how we were doing development, the tools that we had available to us in order to write code, build systems, build integrations. And that's something that we continue to do today. And we'll always be continuing to improve, obviously, but DevOps is, it's a buzzword to a certain perspective, but it's probably one of the most important aspects of our job right now is automation in our development practices and the marriage of development and operations, right? It's not just developers and operations anymore. It's not server administrators and development staff. It's the marriage of those two into a cohesive unit that can allow us to do the things we need to do today and tomorrow. The last thing I'll touch on here is infrastructure as code. So it kind of goes into the whole DevOps mentality, but really what we're looking at when we're talking about infrastructure as code is the idea that we're not going to hand deploy servers or services or storage or compute anymore. We're going to be able to define those systems as code, just like we do our software, so that we can store it in source control, so that we can track changes to it over time, right? So if I have a server farm that's providing a service, and we know that there need to be at least 4 servers running in 2 different data centers, and they need to have at least 4 CPUs and 32 gigs of RAM and 200 gigabytes of disk space, right? We're not going to go out and click buttons to do that. We're going to define that in code, in configuration, that can be checked into source control. Then if somebody needs to change that, if they need to say, we're going to scale up to 6 servers, or we're going to change that from 4 CPUs to 8, they're going to change that in the code, and they're going to check that into source control. Then we have checks and balances, and we can bring forth change tracking and change control to say, is there an approval process? Is there a workflow that needs to happen in order for these changes to go through to dev, to QA, to stage, to production, right? To go through the process. So that's where we realize infrastructure as code as an integral part of this process to define as much as we can, hopefully all of it, as a trackable entity that we can understand over time how it's changed, and so on. There's another fun graphic. I don't know how applicable these graphics are now, but This is a cool picture, right? It's fun to look at for a little while to understand all of the different components, all the different services that can go into building a highly available architecture in the cloud. You can see there's probably at least 12 different cloud services involved in this example system here that's supplying a consumer-facing website and, again, an API that's maybe serving a mobile application, right? So many different services that are involved in making this thing tick, and obviously hand configuring all these different services and systems is not scalable. And we want to be able to take this and deploy it, not just into production, but we want to be able to spin up a copy of it whenever we want. Maybe we want to do end-to-end testing in a siloed environment to make sure that we're not making any assumptions about where this thing is going to run, right? We want to be able to spin it up anywhere at any time and have it perform the same functions the same way. So being able to have that full definition of the systems, of the software, of the infrastructure, and being able to deploy it in a repeatable fashion is paramount to the success of those systems. All right, so I'll move on from that. I'll talk about analytics for a little bit. Analytics it's a big deal. It's growing, right? Everybody's talking about it, business intelligence and analytics. There's a lot of growth potential for that market now and over the coming years. So there have been some pretty cool analytics projects we've done recently. The first one I'm going to talk about, we probably built this a year and a half ago, and the story behind this was a group of franchisees, and they had a consortium, or they had some means through which they would get together and communicate about their business, quarterly, every so often. And as part of that, they had a system where they could share anonymized sales data with each other so they could see how they were performing against their peers. The problem that they were running into with that system, or what they wanted to improve upon, was that the process was cumbersome and it took a lot of time. So basically what happened is they would do this quarterly, and they would have to build a spreadsheet with their sales figures in it, and everybody would send their spreadsheet, email their spreadsheet to a single point of contact. And that single point of contact would then take all those spreadsheets, compile them together, and send them to another company that was responsible for digesting the data and creating a report, a bunch of graphs, analytics, right? Mashing the data together and plotting the sales data so that everybody could see how they were performing as compared to their peers. So in order for that whole process to happen, it usually took 1 to 2 months, right, for everybody to get their spreadsheets in, to get it over to the company that was going to generate the report, and a month later get that report back and be able to look at their sales data. So by the time they got it back, the quarter was almost done. They were talking about, the quarter prior. So anyways, we took that system and we built a web app that did the same thing, but in real time, instant gratification, right? So at the end of the quarter, or now at the end of the month, they're doing this monthly, they log into the portal and they go and put their sales numbers into a fillable form in the website. As soon as they click save on that, they're brought back to the report where all of the data sits, and the graphs are ready there. Their data has dropped into it, and depending on how many of their peers have entered their data, they can start to see the results, right? And they can go back over time and see, they can do year over year, they can do by month, a lot of different analytics. So I think I have, a little bit of a screenshot of that, right? Again, all the data is de-identified, it's anonymous, but really, this is the self-service portal, accessible from anywhere, accessible from any type of device. that allows them to get that instant feedback instead of waiting for that long turnaround. Let's see. Okay, move on to analytics number 2. So this was probably 4 or 5 years ago. It's actually looking at getting a refresh pretty soon here. But this is a pretty common scenario, is that we have multiple data sources. Typically, you might have an ERP system. I think in this case, it was GP or Dynamics. And the ERP held some of the data. Some of the data was in another system. Some of the data was in spreadsheets. And for one reason or another, they couldn't get the data into the ERP, at least not in its current state. So the main focus here was to build a data pipeline that grabbed what they needed out of the ERP system, took the spreadsheet data, married them together, dumped them into a data warehouse, and then serviced the report in the tool of their choice for self-service analytics. In this case, when we built it, they did Microsoft Excel, which they connected to this data source, which was SQL Server Analysis Services. So basically you have a data warehouse and fast reporting on top of that, on top of SQL Server. So they could connect Excel to that data source in real time, and then the guy who was really good with spreadsheets built the pivot tables, built the reporting, and they had their always online real-time data source with their data now married together that allowed them to do the reporting that they needed that they weren't able to get out of just the ERP application itself. So looking at what we're going to do next with this is really, we want to be able to front it with a modern analytics tool like Power BI or Tableau, right? To improve accessibility. Accessibility with Excel to SQL Server is still, it's tough, it has its challenges, right? Typically you're gonna wanna be on the network or on a VPN, and there can be caveats even there. So bringing that into a tool like Power BI or Tableau again, where it's web-based and access anywhere, put more of the power into the user's hands in order to build their own reports and so forth. So let's see. And I think that is actually all I have.